All right, so let's talk about Newton's second law of motion. We talked about the first law, we played around with the first law, so you should be very familiar with what the first law says. So here's the second law. Newton's second law tells us, well, actually, Newton's first law tells us that we can't change motion without a force, right? Things are going to keep doing what they're doing unless we apply a force to them. Newton's second law talks about how objects will move if the size of the force changes. So if you just push a little bit versus you pushing with all the strength you have, how is that going to affect how the object moves? So it sounds pretty simple. There are three main ideas related to the second law. The first one is that acceleration is the result of unbalanced forces. So if you've got something that's speeding up or slowing down or changing direction, then it's because there's an unbalanced outside force pushing or pulling on it somewhere, right? A larger force makes a larger acceleration. Again, that's pretty simple and makes a lot of sense. If I push harder, the object's going to go faster, right? And acceleration is inversely proportional to mass. What that means is the bigger the object is, the slower it's going to move. That also makes sense, okay? If I'm trying to push a bicycle versus trying to push a car, I'm not going to be able to move the car very much, right? It's not going to accelerate a whole lot because it's got a lot of mass. So Newton's second law really just talks about the relationship between a force and the acceleration. So unbalanced forces cause changes in speed, direction, or both. An unbalanced force pushing or pulling on an object can change its speed or it can change its direction. The second law, and this is just going over what I just said, says that acceleration is proportional to force. If you look at our little diagram here, okay, as I push with harder force, as our force goes up, so does the acceleration. If I lower the force, then I lower the acceleration. So think about pushing on something like a Matchbox car, okay? If you push really hard, it's going to go really fast. If you only push a little bit, it's not going to go very far. And you can look at that picture. You can look at the different forces here and how fast it's accelerating. So really, this part of the law is super easy. The bigger the force, the bigger the acceleration. The harder you push, the faster something goes. That's all it says. So another important factor of the second law is that acceleration is always in the same direction as the net force. So not only is it going to move as much as the force tells it to, but it's going to move in the same direction that the force is pushing it. Again, pretty common sense, pretty simple. The greater the mass, the smaller the acceleration. So these are inversely proportional. So think about this. I drive a small Toyota, okay? If I am parked or not parked, if I'm stopped at a red light next to a semi truck, the semi truck obviously has a much greater mass than my little car. So when the light turns green, the truck with the greater mass is going to go slower. It's going to be a lot easier for me to go when the light turns green, right? Okay. Again, it works the opposite way too. When something is moving really quickly, it's hard to accelerate it negatively. It's hard to slow it down if it has a lot of mass. So if we're both going, me and the semi truck, me and my little car and the semi truck, if we're both going 50 miles per hour and we need to stop suddenly, my car is going to stop a lot faster. I have less mass, therefore, it's going to be easier for me to negatively accelerate. The truck, on the other hand, has a lot of mass, so it's going to be harder for him to negatively accelerate. So, again, Newton's second law is just talking about the relationship between force and acceleration and mass. The bigger things are, the more force it takes to start or stop them. The bigger the force you have, the faster something's going to go. That's really all this law says. So this slide is just repeating previous slides. I'm going to leave it there for you. You can pause it and read over it again if you want, but it's just saying the same thing all over again, talking about force, and the more force you use, the faster an object will go. This one too, I've already said this, so you can pause this and read over it if you want to, but this one just says the greater the mass of the object, the heavier an object is, it's going to need more force to accelerate. more force to stop it. And if you use a small force, it's not going to accelerate very quickly. And that's it for Newton's second law. Really, this law is just about calculations. We're going to maybe work on some math with this law, but it's actually a really simple law. It's just the idea that there is a relationship between force, mass, and acceleration. That if you want something to accelerate a whole lot, you have to apply more force. And if you have something that is really heavy, that has a lot of mass, you have to have more force to either make it start or stop moving. So that's it. All right, go ahead and make sure you either have your notes filled out or that you've dropped me a question about Newton's second law, either a vocabulary word or something I said that confused you, or maybe you want to ask me a what if question about Newton's second law. But go ahead and get that in now so that we can do our lab over Newton's second law when you come to class tomorrow. Bye, guys.